Hi everyone. So in this video, we're going to work through a Year 12 mechanics question from the AS sample paper on pulleys. So we have here a small ball A of mass 2.5 kilograms, and this ball is held at rest on a rough horizontal table. Now, just a little note about this rough horizontal table. Normally, in most mechanics past paper questions, when you have a rough table or a rough surface, that means there is friction. And usually you would have to utilize the year 13 mechanics formula. Friction is less than or equal to mu times R. Now, because this is a year 12 question from the AS paper, we won't need to utilize that in this question. So just a little note about that. Now, the next sentence, the ball is attached to one end of a string. The string passes over a pulley P, which is fixed at the edge of the table. The other end of the string is attached to a small ball B of mass 1.5 kilograms hanging freely vertically below P and with B at a height of 1 meter above the horizontal floor, as we can see in the diagram. The system is released from rest with the string taut, so that means the string is in tension, as shown in figure 2. The resistance to the motion of A from the rough table is modeled as having a constant magnitude of 12.7 newtons. So as we said a moment ago about the rough table, we're told in this question that that resistance force, so this force against us from the table, is 12.7 newtons. As I said before, normally in year 13 questions with friction, you may have to work that out yourself, but in this question, it's year 12. They give us that force explicitly. Ball B reaches the floor before ball A reaches the pulley. The balls are modeled as particles. The string is modeled as being light and inextensible. The pulley is modeled as being small and smooth, so there's no friction in the pulley. And the acceleration due to gravity G is modeled as being 9.8. And if they don't say that in a question, you assume that G is 9.8, unless stated otherwise. Now for part A, write down an equation of motion for A, and then part II for part A, write down an equation of motion for B. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level maths topics that will come up in your 2027 exams. So now that the 2026 exams are finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018, and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams, and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app, and you'll be able to access all of these 2027 predictions. Now, with any kind of question about equations of motion, this basically means write down F equals ma for both particles. So we're basically finding the F equals ma equations for both particles when we find quote unquote equations of motion. Okay, so what we'll do with this question, as with many or most, well, everybody's question, we'll label the forces on the diagram. So we've got the 12.7 newtons acting on A from the table. Now, what will happen when you release this system from rest? As you can imagine, the motion is going to be going around this way. So A is going to feel the tension force driving A forwards, because remember the string is taut. But B will feel the tension force going backwards against it. B, if you imagine that you are B, you will feel B holding yourself back. Now, B also feels a weight of, or a force of its weight. So the weight of B is 1.5 mass times acceleration G, 1.5 G newtons for the weight. So what we can do now is now write down the equations of motion. So let's do that down here. So part A, part I. So for A, the driving force is T and the resistance force is 12.7. So remember, F in F equals ma stands for resultant force. So the resultant force for A is going to be the T, the tension, minus the 12.7, and that's equal to the mass, which was, I can't remember what that was now, 2.5, and then times by the acceleration, which we don't know at the moment. So remember, when you have a pulley system or when you have connected particles and the string is inextensible, like with every Pulleys question, that means the accelerations for both particles are the same. So we will use the same A value in both equations of motion. So now the equation of motion for B, so that's going to be the weight. The weight is driving B downwards. So 1.5 G for the weight, 1.5 G. And then subtract the tension, the resisting force, and that's equal to the mass, which was 1.5 multiplied by exactly the same acceleration, A. And what I will just do, I'll just calculate 1.5 times 9.8 with this question just to give a value. So this is 14.7, take away T equal to 1.5A. Perfect. I'm just going to call this equation 1 there. And I'll call that one equation 2 as well, because we'll probably need to utilize that in the next question, which we will. Just another quick interjection. If you are currently doing Edexcel A-level maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. So part B, hence find the acceleration of particle B. So remember, as we said a moment ago, the accelerations for both particles are the same because the string is inextensible, okay? So it's the same acceleration for both A and B anyway. So what we can do is we can take equation 1 and equation 2 and add them together. So like simultaneous equations. Equation 1 plus equation 2, that suggests that t plus minus t, the t's now cancel out, on the left side, and that then suggests we have 14.7 plus minus 12.7. That would give us 2. So 14.7 plus and minus 12.7 leads us to 2. And then on the right side, if we add the two right sides, so the 1.5a and the 12.5a, that gives us a 4a. Perfect. So again, as we just said, that's going to be 2 on the left side, that's going to be 4a. So therefore, the acceleration is equal to 0.5 meters per second squared. Perfect. So that's part B done. Now let's go to part C. Using the model, find the time it takes from release for B to reach the floor. Okay, so we've got a distance of 1 meter that we're traveling. Okay, so for B to reach the floor, we're traveling a distance or a displacement of 1 meter. Now, as we found in part B, and as will be the case for all of these Pulleys questions, acceleration will be constant. So remember, what does constant acceleration mean? It means we can use suvat. So we can use suvat since acceleration is equal to 0.5, which is a constant. Okay, so what do we know about the motion of B until it hits the ground? Well, the displacement S is 1, so we can use our suvat letters. S is 1. The initial speed is 0 because remember the system is released from rest. The final speed, I mean, we don't know that for now. Acceleration, we know what that is. That's 0.5. And the question, what was the question about? It was about finding the time. Yeah, so the time is what we want. So the time is what we're looking for. So we don't care about V. Okay, so remember with SUVAT equations, if we have three numbers from SUVAT, we can then calculate one of the other variables. So we have S, we have U, we have A, we have T. What is the equation from the formula book that does not have a V in it? Well, it's this one. It's S equals ut plus half at squared. So S1 is equal to 0 times t, so 0, and then plus a half of a 0.5 and then t squared. So we have 1 is equal to half of 0.5, so 0.25 t squared. So therefore, 1 divided by 0.25 is going to be 4, so 4 is equal to t squared. So therefore, t must be equal to 2. I mean, obviously, t can't be negative. It can't have a negative time. Obviously, t doesn't equal -2 in this case. So the time is 2 seconds, and that's our answer to part C. Perfect. So now then, with the last part, suggest 2 improvements that could be made in the model. So when we get a question like this, we want to look at our modeling assumptions, okay? And we can see what our modeling assumptions are in this paragraph there. So the balls are modeled as particles. I mean, obviously in real life, they're not going to be particles. They're going to be real 3D shapes. The string is modeled as light and inextensible. The pulley is modeled as small and smooth, and acceleration due to gravity is modeled as 9.8. So we've got a couple, well, we've got a few different potential answers we could say with this one. What I'm going to do, I'm going to write down all the potential answers you could say, and then obviously, you know, if you were answering this question in an exam, you just pick 2 of them, okay? You don't need to give them all the 2, but I will write down a few so you can see the different improvements we could make. So the first improvement, we could take into account the shape of the particles, or the shape of the balls, I should say, because we're modeling the balls as particles, right? And they're not particles. We know they're not particles, they're balls. So what we can say as like a first reason, take into account. Sorry, let me write that again because my handwriting there has gone really, really bad. Take into account the true 3D shape of both balls. That's what we could say. Now, as a second thing we could say, again, let's go back to that paragraph about the modeling assumptions. The string is not going, I mean, when we say the string is light, we're basically assuming the string has no mass, but obviously a string is going to have some mass. So take into account the mass of the string is another improvement. So take into account the mass of the string. And we can just say that this would be positive, which would be a value greater than 0. So remember, if a pulley system has some mass, if you've got a string with mass, that will reduce the acceleration because it means the mass of the whole system is bigger. And remember, F equals ma. So if you rise the mass and the forces remain unchanged, then that has to reduce the acceleration just by F equals ma. Sorry, greater value than 0, I should say here. Let's just say here than 0. Great. Now, the third thing you could mention on this question, you could talk about the inextensible nature of the string. So in reality, there probably may be some extensibility. So we could say in reality, the string is likely to be, sorry, the string is likely, again, I'm making a mess with my handwriting here. Do bear with me. The string is likely to be a little extensible. So take this into account. Now, if the string is extensible, we did talk about this earlier in the video. If the string is extensible, it means that the accelerations of the 2 particles will be different. That is because now the string, the string has a different length, because if you can extend the string, that means the distance of the string will be changing. It will be a variable distance. It won't be constant. So if the gap between the two particles or the string distance is changing, that means that both particles have different motions, okay? Because the distance between the two particles is no longer constant. So that implies different motion, different displacement, different velocities, different accelerations. So the next thing we could say in this question, so we talked about the extensibility of the string. The pulley is modeled as small and smooth. Now, in reality, there's probably going to be some friction in the pulley. So you could also say with this one, likely that pulley has some friction in reality. So again, account for this. Account for this. And what else could we say? We could also talk about gravity. Okay, so we're modeling gravity as 9.8 as an acceleration. Now, we could use a more accurate value than 9.8. Okay, so let's say down here, use a more accurate value of gravitational acceleration. Gravitational acceleration. That's always a good one you can say in these sort of questions. Perfect. So hopefully that makes sense on this question. Again, if you've got any queries or comments, do drop a comment below. But hopefully that does all make sense.